Right, now you're in lesson 10, starting with nature of roots, and this is just a basic introduction. Right, what are roots? Now how do we classify them? Right, so we should know by now when I say quadratic equation means first term x squared, second one x with a constant term, can be solved using factorization, quadratic formula, or by completing the square. So when you solve for x, you are actually finding the roots of the equation, meaning when you find the x-intercept, if you remember your graphs, you're finding the roots of the equation, meaning where does it cut the x-axis. So look at the example, I have x squared equal 2x minus 3 squared. Get rid of the squares on both sides, I find square root of both sides, plus minus, that simply stays now 2x minus 3. That plus minus x, so 2x minus 3 equal x, or 2 minus 3 equal negative x. So from there, if I bring x over, 2x minus x gives me x, minus 3 becomes plus 3. There, if I bring x over, 2x plus x would become 3x, and minus 3 go over, become plus 3. 3 divided by 3, x equal 1. So number 1, these two values are different, so therefore they are called unequal roots. 1 and 3 are both rational numbers, therefore they are called rational roots. So here we have two unequal rational roots. So I'm just classifying from what I have solved. Alright, if you look at the second problem, again quadratic equation, y, x squared, xn constant. Alright, using quadratic formula, should know a is 3, coefficient of x squared. B is negative 2, the coefficient of x, always with the sign, and C is 1. X equal minus b plus minus square root b squared minus 4ac over 2a, quadratic formula, so negative stays negative, b is negative 2. Alright, square root b squared will become negative 2 squared, minus 4, a being 3, c being 1. A at the bottom, 3. Negative times negative, positive 2. Negative 2 squared, 4. Minus 12. 4 times 3, negative 12, which gives me negative 8. Now the square root of a negative value is non-real. You should remember that from grade 10. Number systems, therefore the roots are non-real. They do not form part of the real number system. Alright, so in short there I've done nature of roots. In the next slide I'm just going to quickly introduce you to what we mean. Very important, b squared minus 4ac. Alright, now when we say nature of roots, we're going to use the discriminant, b squared minus 4ac, which you saw under the square root sign there. So the discriminant equal b squared minus 4ac to solve the nature of roots. B squared minus 4ac is greater or equal to 0, the roots are real. If it's less than 0, non-real, meaning negative square root, non-real roots. Alright, if we substitute the value of b, a, and c in, and we get a perfect square as the answer, meaning 1, 4, 9, 16, 25, 36, 100, etc., then the roots are real, rational, and unequal. If b squared minus 4ac equals 0, then the roots are real, rational, and equal. So they're unequal and equal. If it's equal to a positive number and it's not perfect square, then it's irrational and unequal. So we'll be testing those three in the next slide when we classify nature of roots. Very important. You can pause, write this down, make sure you understand it. A lot of learners complain and struggle with nature of roots. I'm going to try to make it as simple as possible. Right, continue practicing, nothing but the best. Right, hard work will always lead to success.